Now, dear students, we have learned about how stacks and queue works, right? So today, in this particular video, we will be talking about an applications of stacks. So this, stacks can be applied in different applications, like your reversible of a string, and you have I think you have already studied about string, about string. You have function calls, right? Function calls. And then he- uh, and one more applications is like conversion of infix to postfix form. All right. And at the fourth, in any there are different applications also, like checking validity of an expression containing nested parentheses. So these are the certain applications where this one stack can be used. All right. So so today in this particular video, we will be talking about how this and a very important applications of stacks. So so one important application of stack is in evaluating your arithmetic expression. So this, so application, so just a second. So as I told you that an important applications of stacks is evaluating the arithmetic expressions. Okay, expression. So this is one applications. Now this arithmetic expressions basically consists of operators and operands. All right. So this arithmetic expressions, okay, arithmetic expression basically consists of operators and operands. All right. So where operands, this operator means different type of operators you have already studied in your C. And operands are what? And operands are your maybe either your numeric constant. It can be a numeric constant or numeric variables. All right. So if I say, let me take an example like this: 9, say, plus 6 divided by 3. So this is one example. So okay, so if division is performed, first before addition, then the result would be say it would be 11, right? If division is performed first before addition, result would be 11. While if addition is performed then before your division, then the result would be 5. All right. Now, to avoid this ambiguity, okay, what we are going to do is that we are going to use parenthesis to specify which operation is to be performed first. All right. So so another situation is that each operation is given some so the first option was giving the parenthesis, right? So we give a parenthesis to specify which operation is to perform first. Or we can use, or another solution is that each operation is given some priority. That means each operator has to be given some priority. All right. And the operation which has the highest priority is to be evaluated first. All right. These are the two options to to avoid the ambiguity. All right. So in our discussion we will take 5 operators, that is your plus, minus, this one, multiplications, then divisions and exponentiations. All right. So and the priorities would be like this. All right. Priority would be like this. So these are the uh, five operators that we are going to be considered, and these are the priority. Exponentiation has the highest priority and is given the value 3, and plus and this one multiplications and division has priority second. Priority has divisions given the priority as second, and plus and minus has the same priority, so it is given as priority 1. So you can see that exponential has the highest priority and plus and minus has the lowest priority. Now if these two priority have the same, if these two operator have the same priority, say let's take an example, addition, this one, say multiplications and divisions. All right, in your expression if you have these two operators, now which operator will perform first, because both of this operator has the same priority. So what we are going to do is that then the expression, okay, so the given expression is going to be scanned from left to right, and which operator comes first will be evaluated first. All right, so this property is called as your, we already studied, right, associativity. Okay, and we have assumed left to right associativity for all our operators. Now if we apply this precedence, okay, this precedence rules to our expression, to our given expression example, right, 9 plus 6 divided by 3, then we can see that divisions should be performed before the addition. All right, so but this is a numeric constant. If we take any arithmetic expression, and let's see how we can evaluate it using the precedence rule. So if I take an example like this, a plus b with the exponent of c minus d, say multiplications, and let's say e, and say division f, then minus g h minus h I. Now if you see if I give an expression like this, so which so exponentiation will be performed first, like that means b exponential c will be performed first, and then d and e will be performed second, right, e will perform second, and then third will be performed between b and f, right, this one will be performed. So if let me draw a diagram, all right, so that you better understand. So if I take this, I cannot find this, okay, let me take this. All right, so this b and c will be performed first, right, so this b and c will be performed first. So b and c will be performed first, so the first operation will be b and exponential c, right, and then d and e, d and e, d and e will be performed. All right, so we will take the same arrow and we'll place it here, so d and e will be performed. So this is the second, and the third will be the result of d and this one, d with the e slash f. All right, so if I take the same example here, if I copy this, so let me copy this one, and if I paste it here, so the result of D and E. This will be your third, right? This will be your third. Fourth will be G divided by H. This will be your fourth. So this will be your fourth. Right, this will be your fourth. So this will be your fourth, and fifth will be from the C to A. All right, C to A. So fifth will be fifth will be like this. I'll take this. Fifth will be A plus B will be your fifth, and sixth will be 6. So this is what? This is 6 will be from 6 will be like this. This is your 6. 7 will be from till G. All right, G. In 8 will be from with the remaining I. So this is the first. This is the uh, how we perform the arithmetic expression. So B and C will be performed first, and then D and E. D and it should be D and E here. This should be D and E, not E and D. All right. So this should be performed. So B and C will be the first operation to be performed. Then D into multiplications into E will be second, and third will be the result of D into E will be performed with F. That will be the third steps. Fourth will be G divided H. Fifth will be A with the result of A exponential of C. All right. Then six will be the result of A plus this one from A exponential of plus this one. The result of this will then the result of this one D into D of the result of into multiplication. This is the result of this with this. And then the seventh one will be the result of this, and the result of we'll get the result here. This one 6, and then 7 will be 7 will be from 6 to G minus G divided by H, and then 8 will be from the result of this with the I. So let me write the number also if it's possible. I want to write here. So if I say number 1, so this is your first step. This is the first step, and this is your second step. Right? This is your second step. So this is your this is the third step, and this is your fifth step. This is the fifth step. Sixth step. This is the seventh step. This is the eighth step, and this is your fourth. This is the fourth step. Now, so this the number indicates the sequence of evaluation of operations. If you want to override the precedence rule, then we can use parenthesis also. All right, we can use parenthesis. So this is called as your Polish notation. All right, this is called as your Polish notation. Now we will be learning another applications of stacks. So that is called as your converting infix expression to postfix expression using stacks. So this is a very important topic in stacks. All right, so what basically is infix? Okay, so the conventional method of representing, okay, the conventional method of representing, so I'll give you the definition also. All right, so let me take you the infix means. Infix means the conventional method of representing an arithmetic expression is called infix. All right, it is called infix because, why it is called infix? Because the operator is placed in between the operands. All right, why it is called infix? Because the operator is nothing but your plus, minus, divisions and all that. We have that 5 operators. If these operators are placed between the operand are can be a numeric constant or arithmetic constant, so, or any variables. So if uh, if these operators are placed in between the operands, then it is called as your infix expression, infix notations. All right, now if the operators, if your plus, minus, your divisions and all, if these operators are placed before the operands, then this notation is called as the prefix or Polish notation. All right, now if the operator is placed after the operand, uh, then this notation is called as a postfix or reverse points notation. All right, so we can see that arithmetic expressions can be expressed, can be represented in 3 ways. So infix means a, so let's say a plus b. Prefix means a b, and postfix means a b. So this is called as your uh, different ways of representing your arithmetic expression. All right, arithmetic expression. But here from your syllabus point of view, we will be considering only conversion of infix expression to postfix expression. All right, so and rules to be followed while we perform this infix to postfix expression. All right, I'll just note down the this one, the rules. So please be rules when we solve this. Please don't get confused with the rules. All right. Now, dear students, this is the steps for converting your infix expressions to postfix expressions. So what we are going to do is that in the very first step, first we have to scan the symbol of array infix one by one from left to right. Okay, from left to right. And if your symbol is an operand, then what we have to do is that we have to add it to an array postfix. All right, and if the symbol is a left parenthesis, push it onto the stacks. And if symbol is right parenthesis, what we have to do is that we have to pop all the operators from the stacks up to the first left parenthesis and add these operators to array postfix and discard both the left and right parentheses. And D, if symbol is an operators, pop the operators which have which have precedence greater than or equal to the precedence of the symbol operators and add this pop operators to the array postfix. Then we have to push the scan symbols operator on the stacks. Assume that left parenthesis has less precedence. And after all the symbols of array infix has been scanned, pop all the operators remaining on the stacks and add to the array postfix. Now this is the some of the steps to have followed while evaluating the expression from infix to postfix. So let me take an example. We will see here I've taken an arithmetic expressions. This arithmetic expression is basically an infix expression in infix notations. Now we have going to perform this infix to postfix. So very in the very first step, what we have to do is that first we have to scan the symbol from left to right. So we are going to scan the symbol from left to right, so we start scanning the symbol from A. Okay, from here, start from here. So we will write the first. So when you scan from left to right, we encounter the very first symbol, right? That is A. So what we have to write is, we have to write A. Then what action we need to perform? So we need to perform, what is the actions? Add to the add to the so we will add A to the postfix. So why I have written like this? Because in the rule number 1, if the symbol is an operand, all right, so what do you have to do? Simply we have to add it to the array postfix. All right, that's why I have written the action is add to the this one. All right, so in the very first, the stacks will remain empty. All right, and then just simply write the symbol A. All right, symbol A. And the second, let's scan again. Scan. When you scan this, you encounter, let me, all right, so in the second step, the next symbols that we encounter is plus. All right, so plus. So if the symbol is an operators, what we have to do is that we need to push on to the stacks. Okay, when if you have any symbols, then what we have to do is that push on to the onto the on the stacks. All right, and the stacks will be plus. All right, and then postfix will remain the same. All right, so we have to write like this. Again, in the step number 3, we have another expression, right? So B will be here, and then what we have to do, we need to add B to the postfix. So what is this symbol? What is the stack? Stack will plus. What is the postfix? Postfix will change to A and B. All right, again the fourth step, right? Fourth step, what we will encounter, we have slash, right? We have slash, that is a divisions. And then what we have, if we have a divisions, what we have to do, we have to simply push on the stack plus. Then what we have to write, A, B. Yes, but here you see that A, what is the symbol here? A, it need to be added. All right, A and B. Again, fifth. So fifth is C. If it is C, so C will be here. What we have to do is that push on the stack plus what is the new value that is, or what is the new symbol that has been added? Then C, right? So we will have to write A, B, C. Then 6. In step 6, what is this? Multiplications, right? Multiplications. Then what we have to do is that if we what if the symbol is an operator, if an operator, what we have to do, we have to pop the divisions. We have to pop this in order to bring right here. We need to pop this. All right, pop this divisions. Pop. All right, and add it to postfix, and then push on the stacks. So this division will be removed, will be popped. Instead of that, then we will add this multiplication symbol will be push. So plus, and then this pop will be added to the postfix. So this is a postfix, right? So it will be added here. A, B, C slash. All right, this will be slash. Next is 7. What is the, we have a left parenthesis, right? We have a parenthesis here. So what we have to, parenthesis, just push it, push on the stacks. So what we have to do, so just push it on the stacks plus multiplications and then push. That's all, push. When you push this, what will you encounter? Just the same, the postfix will remain the same. All right, then what is the next thing? We have wait operators operand here. E, right, add E to the postfix. Same, it will remain same, there is no changes. All right, there's no changes. So A, B, C slash and E, it will be added. All right, what is that? It's not B, it is D. I guess it's D. It should be D, not E. All right, and then next step is 9. 9 means, so bring down plus. So what you have to do? Push on to the stack. Push on the stack. Plus multiplications, parenthesis, and then plus A, B, C slash D. Then what is this? Next is 10. We have another variable that is operand. No, this should be add on to the add E to the postfix plus A, B, C slash D and E. This will be added. All right, then we have the right parenthesis. So when you encounter right parenthesis, what we have to do? So what we have to do? Parenthesis pop there. So what is the elements to be pop? Plus. Okay, pop plus pop plus and add to the postfix. So it is pop, right? Asterisk. So this, and then so this is removed, right? So this is removed, so this will gone. Then what will be remaining? It will remain as plus and minus. This one plus and multiplication. So we have a b c slash d e will be, then we have plus. All right, then we have plus. Then what we have next expression? The next expression, what is the next expression? We have minus f 12. So minus, what is the minus says? Minus says pop at plus and should be n plus add them to postfix and then push. So this will be only plus, this will be pop, and then what we will have a b c slash d e plus, and then x, right? Then we have plus also will be pop. All right, and then at last we have, and then we have in 13 we have f, right? F will be added, so just add to the, so add f to the postfix. So minus we will have, then a b c slash d e plus divisions plus f, and then at the last we have only one remaining operator, is the operator is remaining, that is a minus is remaining, so there will be no symbols. What we have to do? Pop minus and add to the postfix. So we have, so your stack will be empty now, and then we will get a b c slash d e plus f minus. So this is the postfix operation. Now you see here, so this is how we are going to evaluate your infix to postfix. Now you see here in step number 2, all right, in step number 2, the plus symbol, the operator plus is simply pushed onto the stack since the stack is empty. All right, since the stack is empty, now in step number 4, first we will have to compare. All right, first we have to compare the precedence of uh, divisions with that of the top operator of stack, which is plus. All right, this precedence, this one, we have to compare the precedence of divisions with the top operator of the stack, which is plus. All right, since the precedence of plus is less than that of this one divisions, what then we will not pop any operator and simply push. So we will not pop anything, but simply we have to push a division on the stacks. All right, push division on the stacks. And in step number 6, All right, in step number 6, since we were going to compare the precedence of this multiplications with that of the top operator of stack, which is, what is the top operator here, which is division. This is divisions. Since the precedence of multiplication is equal to the divisions operators, so operator this one, they have the same precedence, right? So operator division is pop and added to the postfix, and now the top operator of stack is is plus. All right, so now we will compare precedence of multiplications and with that of uh, positive plus operators. Since the precedence of plus, all right, since the is less than that of multiplications, now operator this multiplication is push onto the stacks, now in step number 9, what we are going to is that in step number 9, this plus is simply push onto the stack. All right, since we assume that the precedence of left parenthesis is less, okay, is less. In step number 11, we have to pop all the operators on the stacks. No, we have to pop all operators till left parenthesis, okay, till left parenthesis. So plus is pop and added to post. In step number 12, what we are doing is, in a precedence of precedence of multiplications is greater than that of minus, and so multiplication is pop and added to the postfix. Now top operator is on the stack is plus, and its precedence is equal to that of multiplication minus, so it is also pop and added to the postfix. After this, minus is pushed onto the stacks. And in step number 14, all the symbols of the expression has been scanned. So now we have to pop all the operators from the stacks and add it to the postfix. Okay, the only operator remaining on the stack is your minus sign. So it is pop and added to the postfix. So this is how the conversion of infix to postfix works. Now, taking the same different examples of conversion from infix to postfix, you can see that I have written an infix arithmetic expression. Okay, so how will you convert this infix expression into postfix expressions? So it is given like this. So how will you convert this infix to postfix? So what we are going to do is that in the very first step, so we take the variable a, right? So we take the first operand a, right? So when symbol a is taken, so stack will remain empty and your postfix will be a only. All right, now the next symbol that we have to undertake is exponential. So in the step number 2, we have to take the this one, exponentiation. Then this one exponential, this one. So what we have to push on the stack. So I have not mentioned the actions. Okay, you can mention or you don't mention, it's up to you. All right, so when exponential when symbol this one exponential arrives, what does this mean? This means just push on to the stacks, push on the stacks. All right, and your stack will remain, stack will also be your exponential. Just this exponential will be push on the stack and your postfix remain as a. All right, next b. In the third of steps b, when b arrives, so one b means what we have to do, we have to add b to the postfix. So stack will remain this exponential, and then we have to add a and b, a and b. Again, the next step, fourth. In the fourth step, when we have this symbols, when these symbols arrive, okay, when these symbols arrive, this symbol is compared with the exponential. All right, but exponential has the highest priority, right? Exponential has the highest priority. What we have to do is that, so this symbol, this multiplication symbol has to compare with the exponential, and this and then the higher priority, okay, this exponential has a higher priority, so this exponential will be pop and add to the postfix. All right, once it is pop, then this multiplication symbol will be pushed onto the stacks. So in the stack, this will be push. All right, this will be push, and then this will be pop out. So this will be pop out, and it will be added to the postfix. So you will get answer like this. All right, you get the answer like this. Next, in the fifth step, now C is arrived, right? C is arrived. The stack will remain the same, and then we just have to add to the postfix. All right, we just have to add to the postfix. Next, in the step 6, what we have to do, then we have this division symbols. When division symbols arrives, what they have to do is that we have to compare, okay, we have to see the previous stacks. So in the previous stacks we have multiplications, but the new symbols arrive is divisions, right? So these two will be compared. But you see, but as we have seen in the this one, that this two notation has the same priority, has the same priority. So what we have to do, we just have to pop this previous symbol which is in the stacks. So this will be pop, and then the symbol division will be pushed onto the stacks. So when it is pop, it will be added to the postfix. All right, so your postfix will be AB exponential C, then this will be pop. In the place of stack, the divisions will be placed, push on the sticks. All right, in the seventh step, so in the seventh step, what will we have? We have the left parenthesis, right? We have left parenthesis. When left parenthesis assign, all right, when left parenthesis comes, so what left parenthesis says, in the that's just you have to push on the stack, push on the stack. So this will be push on the stack, so it will be push on the stacks, means in the previous stack, in the stack we have divisions, right? So it will be push on the stack. So this was the previous item here, item symbols, then we have to push. All right, so it will be push. All right, and the postfix remains the same. Postfix remains the same. And then we have 8. All right, in the 8 what do we have? We have the variable d, so stack will remain the same, and then it will be added to the postfix. All right, then what we have to do in the step number 9, we have this symbol asterisk. All right, so this multiplication symbols is arrive, then it will be compared with the this one. All right, so what we have to do, so we just have the left parenthesis. If there is no left parenthesis, then this multiplication and divisions will be compared. But as we have this left parenthesis, we just have to push this on the stack. So push onto the stack, and then postfix remains the same. All right, postfix remains the same. All right, so this postfix remains the same. Then variable in the step number 10, we have variable operands e has arrived, and the what will so in the stack we just have to add on the this we have to add this symbol to the postfix. Stacks will remain the same. B C, then this will be D, and then E will be added. All right, so in the step number 11, step number 11, what we have minus sign, right? We have minus sign, then but you see here we already have, after the left parenthesis we have a asterisk symbols, but this asterisk symbols will be compared with the new this symbols minus, so it will be compare multiplications, and minus will be compare multiplications have asterisk have higher priority, so this will be pop and added to the postfix, and then minus sign will be added push on the stacks. So this will be push on the stacks, so minus will arrive, what will be pop out, the asterisk symbol will be pop out, and then asterisk symbol will be pop out. Then what this is the next symbol that has been arrived, the next symbol arrive is E, this F. So just add to the postfix, right? We just have to add to the postfix, right? And then F will be added. After that, what is the last symbols it has been left? The last symbol, this one, 13. So when we have this, when this arrives, all right, when this arrives, the stacks, so what will happen, we have to what so what we have to do, we have to push all these stacks. All right, so what we have to do, so the left parenthesis in the stack, it will be only the divisions will be left, and the remaining will be added to the postfix. C asterisk DE asterisk F, and then minus. All right, and then minus, and the last one what we have to do, so in the last steps the stack will, yeah, here we have no symbols left, right? So stack will be empty now, and this will be, so after all the symbols of array infix has been scanned, what we have to do, we have to pop all the operators remaining on the stack and add to the postfix array. That means whatever the symbols or whatever the operators, all right, all the symbols see, we have already done with all the symbols. All right, we have already scanned the symbols, infix. Then what we have to do, we have to pop all the operators in your stacks and add it to the that is the remaining this one will be pop and added to the array postfix. So we will have A, B, C, then we have this, DE F minus, and then we have the division. So this is one example of infix to postfix. All right, next we will be doing about evaluations of a postfix expression. Now this is one example of arithmetic expression. If I give you some numeric this one numerical value of conversion of infix to postfix, so how will you do? We will take one examples. Okay,